Assalamualaikum and hi everyone. So welcome to my series where I'll be covering all of the chapters for Form 4 AddMaths. But basically I'm just going to be covering the basics that you need to know when answering a question. Inshallah, what I'll be teaching will help you tackle the harder questions because what you really need in AddMaths is a strong base. Alright, so let's get into it, yeah? Alright, so today we're going to be looking into functions. So functions have actually four things to be known, which are the types of functions. So then we also have the components of a function, followed by composite functions, and lastly, inverse functions. So these are the things that we're going to be going through for today. So let's go over the components of a function. So usually functions would be drawn with these two ovals with numbers or even unknowns. And usually they would draw these arrows to show that whatever on the left is going to whatever on the right. Now, all of these things here have names actually. For example, this oval on the left is called the domain, whereas this oval on the right is called codomain. Sometimes the question may ask you to write them, and in this case the domain would be set notation 1, 2, 3. But the codomain, same thing, set notation but whatever is on the right, A, B, C. Now, those elements inside also have a name, which is object and image. If you were to write them out, you would just have to write whatever is inside, the numbers or the unknowns. You wouldn't have to write the set notations. But then you have something called range. So let's imagine I erase this arrow right here. Okay? Basically, range refers to whatever is the image in the object. So in this case, it would be A and B. So whatever has an arrow is a range. Whatever doesn't have an arrow going to it is not a range. But the range is basically the image. Now, there are a few types of functions that we have to know. 4 of them being one-to-one functions, one-to-many functions, many-to-one functions, and many-to-many functions. Now, let's see how these look like. I'm just going to be drawing all these ovals once again. Let's remove that line over there. I'm just going to draw all of them again. Now let's just imagine these dots are elements, because writing a number over and over would be too long. Now, one-to-one functions would just have one object going to one image. But for many-to-one functions, it's basically multiple objects going to one image. One-to-many is the opposite. One object going to multiple images. Then there's many-to-many, a mixture of both. Out of all the 4, only 2 are counted as functions, which are one-to-one functions and many-to-one functions. Therefore, one-to-many and many-to-many are not qualified as functions. Alright, now let's look at an example of a function. So usually functions will be written like this or even like this. Basically, both give the same meaning. Now, usually questions would ask you, find the image of -4. That would mean that -4 over here is the object. So how do we find that? Usually, you would just put -4 into the x in fx. So I'm going to be using this right here as my example. So let's just write it back down. Fx equals 3x plus 2. Now I want to find the image of -4. So I'm putting -4 into my x over there. So it's almost like subbing the equation. -12 plus 2, -10, alright? Now let's imagine I want to find the object of something with the image of 8, right? So then it would be the opposite. You could say that fx equals to 3x plus 2 equals to 8. So just like solving an algebraic equation, you just have to bring stuff around, and here you get x equals to 2. That means in this case, the object will equal to 2 when the image equals to 8. Now, there are certain questions which may get a bit tougher. They'll actually ask you about finding the object which maps onto itself. This is a bit tougher one, but once you understand the concept, it's actually easy. Now, this refers to when the object equals to the image. So basically, what you have to do is just write back down the equation. Fx equals 3x plus 2 equals to x. Solve it like a normal algebraic equation. 2x equals to 2 and x equals to 1. Just like that. Alright, now let's look at composite functions. So what a composite function is basically two functions being molded together. So I've already given two functions, f and g. Basically, I can make any composite function I want. I could make composite function gf, or I could even make composite function fg. I could even make composite function g squared if I wanted to. But let's just discuss how we get these functions. So I'm going to take an example. Let's find function fg, all right? Function fgx. All right. So the way I would get this is to rewrite this as f bracket function gx. It's basically saying that I'm putting g into f. So what is g? Let's write that back down. It's 1 minus x. I'm basically subbing in the values, all right? So 1 minus x is going to where x is, to 1 minus x plus 3. So if I expand this, I would actually get 2 minus 2x. I get 5 minus 2x. And that is exactly what function fg is, all right? All right. Sometimes they will actually give you certain composite function questions where they want you to find the base function. For example, they give you the function fg, they give you the function f, but they don't give you the function g. Basically, you have to find what this function is. Now, let's use the values as just now. We know that fgx equals to 5 minus 2x, and we also know that function f equals to 2x plus 3. So how am I to find the function g over here? All right, let's rewrite this. Function fgx equals 5 minus 2x. I could bracket this gx to make it like it's an unknown. So I could sub gx into my function of 2x plus 3 over here. So I would actually get 2g plus 3 equals 5 minus 2x. Now solve it like a linear equation. I would get g equals to 2 minus 2x over 2. And that will give me function gx equals to 1 minus x, which is exactly what we're looking for over here. Then there are situations where they give you function fg, they give you function g, but they don't give you function f. So let's find function f this time. Let's just write back down fg equals to 5 minus 2x and g x equals to 1 minus x. So let's just do it again. Let's bracket everything. So I could say function fg, I could put its value inside f1 minus x equals 5 minus 2x. Basically, the way you approach this is to always just sub in values. But this time, we're going to let 1 minus x equals to y. Now, we got to find what x equals to. Basically, make x the subject. So if I were to manipulate this, I get x equals 1 minus y, right? So then I could actually rewrite this function as function y, which would equal to 5 minus 2, and sub in the value here into x, all right? So 5 minus 2, 1 minus y. So if I were to expand this, I would get 5 minus 2, 3 plus 2y. Therefore, I could actually find function f just by comparing it. Basically, this function y is also function x. And there you have it. Got the answer already. Alright, so now let's look into inverse functions. So basically, let's imagine how this looks like. I'm going to give you guys a function. Now, basically, this is x, and this is the image fx. So when you go over here, basically x will be under the function of fx over here. But how would you want to put whatever is fx back to x? That's when the introduction of inverse functions come in. Basically, inverse functions are the opposite of functions. Instead of going from object to image, it's like going back from image to object. So, how do we find the inverse function of fx? In this case, we have to start by letting the inverse function, become y, and then you can actually manipulate this to become function y equals to x. So basically, what is function y? Function y is actually the same thing as just putting in the value of y into x. Now then, you just have to make basically you can equate this to where it becomes x equals 3 minus 4y. Now you got to make y the subject, and you'll see y soon enough. So basically, negative 4y equals x minus 3. Y equals x. Sorry about that. It's supposed to be y equals 2. 3 minus x over 4. Now, the fact that we found y, we've basically found the inverse function, because this can be written back as inverse function f equals to 3 minus x over 4. That's the answer right there. Alright, now let's say that you're not confident with your answer of your inverse function f. Well, I can actually prove to you that I'm correct right here. So remember how I said that the inverse function is basically from image back to object. So basically, let's imagine like this. Function f will be going from object to image, whereas image to object would be the inverse function of f. So let's say I want to sub in a value. So I'm going to let x equal to 1, right? I'm going to test my inverse function. So, but first I have to test it into the function, which is function f. So let's say f1. I'm going to say f1, right? f1 equals to 3 minus 4 equals negative 1. So basically, this is the image right now, right? Since we know that x equals to 1 is the object. So if I were to put this value right here back into my inverse function, if I were to get the same value, which is x equals to 1, the object that we put in, basically our inverse function is correct. So let's try that out. Inverse function, let that equal to negative 1, alright? Don't forget that. So it becomes 3 minus negative 1 over 4. It's the same thing as 4 over 4, so it's 1. Therefore, we've actually already proven that our inverse function is correct. Alright, so now, before I end this video, I just need to point out one more thing about functions. So basically, there are going to be some trick questions where they want you to find the composite function of something. So usually they will draw these diagrams, and then they will say that x going over here is under the function of fx, going over here is under a function of gx. Now then, how would I want to prove function x all the way to gx over here? Basically, you can't jump the gun saying that the whole function over here is the same thing. It's going from left to right. fg, right? Wrong. It's supposed to be gf. Basically, the way I remembered it is I would have to go from left to right, alright? So it's left to right. That's the easiest way to remember when it comes to these kind of questions. But either way, it's the same thing as constructing your own composite functions, so it shouldn't be as complicated once you get how to find them. Alhamdulillah, so that is the end of my video. I hope you found it beneficial, and please look forward to the next chapters which I'll be covering. Thank you very much.